Dynamic heads. Dynamic head is the net effect of all four head factors that contribute to pressure when the pump is moving liquid. 1. Static head. 2. Pressure head. 3. Friction head. And 4. Velocity head. Dynamic head can be calculated for the suction, discharge, or both sides of the pump. For the suction side of a pump, the dynamic head value depends upon whether we are pumping from a suction lift or suction head situation. Dynamic suction head. When the pump is located below the suction source, then static suction head, static pressure head, and suction velocity head, all three act to increase the pump suction pressure, and suction friction head acts to reduce it. The result of the above four factors acting on the suction side of the pump, if the source is located above the pump, is called dynamic suction head. So in a static suction head situation, dynamic suction head equals static suction head plus suction pressure head plus suction velocity head minus suction friction head. Example 3. In a static head scenario for water at 50 degrees C, static suction head is 10 meters, friction head is 1.5 meters, static velocity is 2.4 meters per second. The pump takes suction from an open tank. What is the dynamic suction head? So here's our example. In a suction head scenario for water at 50 degrees C, static suction head is 10 meters, friction head is 1.5 meters, suction velocity is 2.4 meters per second. The pump takes suction from an open tank. What is the dynamic suction head? Step 1, calculating suction velocity head. Suction velocity head equals the velocity squared divided by 2 times g. Suction velocity head equals 2.4 meters per second squared divided by 2 times 9.81 meters per second squared. Suction velocity head equals 0.3 meters. Step 2, calculating suction pressure head. We are going to use absolute pressure for this system. So, first thing we have to do is find the relative density of water at 50 degrees C. From our steam tables, at 50 degrees C, VF equals 1.0121. Relative density equals 1 divided by VF. Relative density equals 1 divided by 1.0121. Relative density equals 0.988. Suction pressure head equals suction pressure in kPa. I'm going to use absolute values divided by relative density times G. Suction pressure head equals 101.3 kPa, which is atmospheric pressure, divided by a relative density 0.988 times 9.81 meters per second squared. Suction pressure head equals 10.45 meters. Step 3, calculating dynamic suction head. So, we're given our static suction head of 10 meters, which is our length from the top of our level in our tank down to our suction line. Our suction velocity head we calculated as 0.3 meters. Our static pressure head we calculated as 10.45 meters. We were given our friction head of 1.5 meters. For a suction head situation, dynamic suction head equals static suction head plus suction pressure head plus suction velocity head minus suction friction head. So basically, dynamic suction head equals our suction static head of 10 meters, our suction pressure head of 10.45 meters, plus our velocity head of 0.3 meters. So basic minus 1.5 meters of friction head. So our dynamic suction head works out to 19.25 meters. Note, in a dynamic suction head situation, static pressure and velocity head all push liquid to the pump, and only suction friction head resists flow. So in this case, a positive value for a dynamic suction head will ensure liquid flows to the pump suction. When the pump is located in a static lift position, the suction pressure head and suction velocity head act to increase the pump suction pressure, and static suction lift and suction friction head act to decrease it. The result of the above four factors acting on the suction side of the pump, if the source is located below the pump, is called dynamic suction lift. So in a static suction lift situation, dynamic suction lift equals static suction lift plus suction friction head minus suction velocity head plus suction pressure head. Example 4. In a suction lift scenario for water at 4 degrees C, static suction lift is 10 meters, friction head is 0.5 meters, and the velocity is 3.4 meters per second. The pump takes suction from a vessel at 200 kPa. What is the dynamic suction lift? So, example 4, we have a static suction lift of 10 meters from the top of the water level to the center line of the pumps, 10 meters. Friction head 0.5 meters. The velocity of our fluid is 3.4 meters per second. And we have a vessel pressure of 200 kPa. What is the dynamic suction lift? Okay, step 1, finding the suction velocity head. Suction velocity head equals the velocity squared divided by 2 times g. And our velocity was 3.4 meters per second. So it works out that our suction velocity head in meters is 0.6 meters. Step 2, finding the suction pressure head. Suction pressure head equals our pressure in kPa divided by g times the relative density. Suction pressure head equals 200 kPa divided by 9.81 meters per second squared times the relative density of 1.0. So our suction pressure head is 20.4 meters. Step 3, finding the dynamic suction lift. So our static suction lift was 10 meters. Our suction friction head was given as 0.5 meters. Our suction velocity head we calculated was 0.6 meters. And our suction pressure head we calculated as 20.4 meters. So because we are in a suction lift situation, dynamic suction lift equals static suction lift plus static friction head minus suction velocity head plus suction pressure head. And if we plug the numbers in, we figure, we do our calculation, dynamic suction lift works out to minus 10.5 meters. Note, because dynamic suction lift is a negative value, the pressure caused by suction pressure and velocity head will overcome the resistance to flow caused by the sum of suction lift and friction head, and liquid will flow to the pump suction. If the value of dynamic suction lift were positive, the resistance to flow would be greater than the pressures causing flow, and liquid would not be drawn into the pump suction. Dynamic discharge head. Dynamic discharge head is the sum of all the equivalent head pressures the pump must overcome to pump liquid on the discharge side of the pump. Dynamic discharge head equals static discharge head plus discharge pressure head plus discharge friction head plus discharge velocity head. Note, all four factors that contribute to head pressure on the pump discharge side act to resist pump flow and increase head. Example 5. What is the dynamic discharge head in the pumping scenario to the right if velocity head is 2.3 meters and friction head is 1.2 meters? Relative density of the liquid is 0.83. So basically here is our question here. We have a static discharge head of 10 meters from the center line of the pump to the top of the liquid on the discharge side of the pump. So we are given our velocity head, so we don't have to calculate that. We're not given the velocity, we're given the actual head. We're given the friction head, so the only thing we should have to calculate is our discharge pressure head. Now we are given that it's an open tank, so our pressure on the top of the tank is 101.3 kPa absolute. So discharge pressure head in meters equals the discharge pressure in kPa divided by the relative density times G. Discharge pressure head equals 101.3 kPa. We're given the relative density of 0.83, so that's times 9.81 meters per second. So our discharge pressure head works out to 12.44 meters. Step 2, finding the dynamic discharge head. Static discharge head is 10 meters. Discharge pressure head is 12.44 meters. Discharge velocity head we were given as 2.3 meters. Discharge friction head we were given as 1.2 meters. So dynamic discharge head equals static discharge head plus discharge pressure head plus discharge velocity head plus discharge friction head. So the sum of all our four heads, 10.0 meters, 12.44 meters, 2.3 meters, 1.2 meters. So our dynamic discharge head is 25.94 meters. Because we are dealing only with the discharge side of the pump, it doesn't matter if it is a suction lift or suction head situation. The dynamic discharge head will be the same.